Mr. Minnick helping students learn some graph theory, and let's start with this worksheet and exercise 1. First, you have to take the given graph and turn it into its adjacency matrix. Just ignore all that flickering, I'm sorry about that. So here we go with my red pen. So this has got 5 nodes to it, and I'm going to build an adjacency matrix, and I'll come back later with that done. So that was quick. I made the adjacency matrix based on this graph. So for example, there's a directed path from A to E, and this would be the A row, and this is the E column, and that one right there represents this arrow right here. I explain all that in a different video. For B, the fact that this arrow circles back to itself, that's represented by this one right here because it's row B and column B at that point of intersection. Now, to find the number of paths of length 2, let's consider this matrix to be named M. So I'm just going to say, hey, M equals this matrix. Well, if you take M squared, then find the sum of all of the elements in that array. I said array, I meant matrix. The matrix M squared, if you add up all the digits, the numbers that are inside of it, that would be how many paths of length 2 there would be. So let's just find some paths of length 2 right now just for kicks. You could go from A to B and then B back to itself again. So A to B and then to B again. That would be a path of length 2. Not to be confused with just AB, that's just the one. How about going from, oh, this is hard, D to C to A. Yep, that's a path of length 2. From D to C to A, because the arrows do go in that direction. Well, it would take forever, and you wouldn't be sure if you hit them all if you just casually visually inspected and tried to find all the paths of length 2 manually. So here's how we do this. We make the adjacency matrix like I already did, and we square it. And so to square a matrix, perhaps you haven't learned how to multiply matrices before in your mathematical career. So I'm going to be the person who shows you that perhaps in this video. You rewrite the matrix next to itself carefully, neatly, and you line them up, in other words, like this. And then you take a row from the matrix on the left, and you pick it up in the air, which I can't show you in this video. So we pick up this row right here, that first row. I pick it up, I turn it 90 degrees clockwise to the right, so that then I lay it down on top of this first column, so that these 5 are laying on top of these 5. So that would put this 0 on top of that 0. And I multiply them together. So 0 times 0 is 0. Then I add that to whatever the 1 multiplied with that 0 would be, because that 1, if you followed me in your visual mind, that 1 laid on top of that 0, and 1 times 0 adds up to something. That 1 times that 1 makes some sum. Then I add that to whatever that 0 times that 0 is. And then I add that to this 1 times that 0. So basically I built this mathematical expression down here, as sloppy as it is, and I simplify it. So 0 times 0 is 0, plus order of operations, you have to do multiplications first. 1 times 0 is 0, plus 1 times 1, plus 0 times 0, plus 1 times 0. And now that simplifies to the number 1. 1. So that answer, that 1, is what you put in your answer here, what we call the resultant matrix, I don't have much room here in this video. So the point of intersection between this row here and that column, the point of intersection where if we kind of laid them on top of each other by not rotating, would be this position at the top corner, which we call row 1, column 1. So this 1 plugs into this spot. All that work just to find out that 1 goes there. Oh, geez. Now I have to change colors here because otherwise it'd be confusing. Let's now pick up this row, turn it 90 degrees, and lay it on top of this same column. And find the coordinates in purple that we would get from doing that. I would have 0 times 0 plus this 1 times that 0 plus 0 times 1 if you're following along plus 0 times 0. And a lot of this you can do in your head, especially when it's zeros and ones, but for now I'm just doing it manually to show you how this is done as partial steps. Going a little faster now, as you see here. That was at times I messed up. And all that simplified to just 0. And where do we put this 0? That 0 goes right there because this row 2 intersected with column 1 over here is the spot 2, 1. If you do this picking rows up on the left matrix, rotating 90 degrees and dropping them on the matrix to the right, you'll end up with the final resultant, which is the product of these two matrices. We usually use a dot operator to show this operation, dot. You would not use a star and certainly not an X from like elementary school. Let me pause the video here and fill in the resultant. Okay, there you go. That's a little sloppy there. That was a 2. So the result of m squared, which was this original adjacency matrix times itself, is this. If we add up all the numbers here, 1 plus 2 is 3. I'm doing this in my head. Plus that 1 is 4. Plus that 2 is 6. Plus that 1 is 7. 8, 9, 10, 11, 12, 13. The answer is 13. There are 13, believe it or not, 13 paths of length 2 in this graph. Somebody had asked the other day, how is that 2 there? Well, let's just pick up this row, drop it on this column, and you'll end up with that 0 times that 1, which is 0, plus this 1 times that 1, which is a 1, plus this 1 times that 1, which is a 1, plus this 0 times that 0, which is 0, plus this 1 here times that 0, which is a 0. Simplify all that, 0 plus 1 plus 1 plus 0 plus 0, it comes out to 2. That 2 is that 2 there. Hopefully this helped, and heaven forbid you have to multiply an adjacency matrix times itself again. In other words, this would be m cubed to find all the paths of length 3 in problem number 5. And by the way, when you multiply matrices, it's not commutative. So you always got to work from left to right according to order of operations of matrix algebra. Unlike math, where 2 plus 3 is the same as 3 plus 2, a square matrix times a square matrix is not the same thing as the guy on the right times the guy on the left. In other words, it's got to be left to right. Good luck.